Welcome to the next chapter of Mathematics, Chapter 6, Simultaneous Linear Equations. Or you can say linear equations, pair of linear equations in two variables. That's another name for this chapter. Pair of linear equations in two variables. Now that says it all, what this chapter is all about, but still we'll have a proper introduction according to the textbook and then we'll start solving the questions. Okay, so an equation of the form ax plus by plus c is equal to 0. Remember, ax plus by plus c is equal to 0 is called a linear equation in which a, b and c are constants, real numbers. X and y are variables, each with degree 1. What is the power of x and y? 1. And that's why this equation is called linear equation. But how many variables are there? 2, x and y. That's why this equation is called linear equation in two variables. Now consider two linear equations, 3x plus 4y is equal to 6 and 8x plus 5y is equal to 3. Both these equations contain same two variables, that is x and y in each case. Together, such equations are called simultaneous linear equations or pair of linear equations in two variables. That's what we have to study in this chapter, pair of linear equations in two variables or simultaneous linear equations. For example, 2x minus y is equal to 1, 3x plus y is equal to 14, x is equal to, okay. These are the examples. This is one more example of pair of linear equation in two variables. Now, if in these two equations we put the value of x and y as 3 and 5, what would happen? The LHS would become to the RHS. Okay, that means x is equal to 3 and y is equal to 5 will satisfy both the given equations. Therefore, x is equal to 3 and y is equal to 5 is the solution of the simultaneous linear equations under consideration. So, the idea behind this whole chapter, simultaneous linear equations, is to solve these simultaneous or you can say pair of linear equations in two variables and find the value of x and y. Okay, and we will be choosing different methods for solving simultaneous linear equations. Out of different algebraic methods for solving simultaneous linear equations, we will be discussing elimination by substitution, that's going to be our first method, elimination by equating coefficients, second method, and the method of cross multiplication. We are going to focus only on these three methods. Out of which, in this first video, I'm going to discuss elimination by substitution, the solved examples which you see over here, and elimination by equating coefficients. That's the second method which you see over here. Method of cross multiplication I will be discussing, but in the third video. In the second video. Okay, after cross multiplication, there are some equations which are reducible in the form of linear equations. For that, I'm going to make the third video. And then there are numeric, you can say word problems based on simultaneous linear equations. So we are going to see these word problems, and as you can see, 5, 6, 7. There are, I can see 7 parts of this chapter. And there are total 21 solved examples. So we are going to do all of them in different videos, maybe 3 or 4 videos. We are going to finish this chapter. Okay, and the remaining exercises, that is up to 6G, all the questions will be given as homework. So huge homework is coming your way. Let's start. Let's begin. Okay, so the first question. Solve the following system of equations using the method of elimination by substitution. The first question is x plus y is equal to 7. I will put a semicolon. And the second equation is 3x minus 2y is equal to 11. Now see, we are using the method, remember we are using the method of elimination by substitution. Now what is this method, elimination by substitution? Please pay attention. So in this method what you will do is you will select one of the given equations. This is equation number 1, this is equation number 2. Which equation should we select? We should select such an equation which is more simpler, which has got the coefficients of x and y, or x or y, as 1. See, here the coefficient of x is 3, here the coefficient of y is minus 2, here the coefficient of x and y both are 1. So out of these two equations, if you ask me which is more simpler one, the first equation is more simpler. So I'm going to select the first equation. Okay, so I'm going to write it here again. X plus y is equal to 7. Now from this equation, I'm going to find the value of either x or y. So let's find the value of x. So x will be, so this implies that x will be 7 minus y. So what we did is we found the value of x in terms of y. Now we are going to substitute this value of x in the second equation. So I'm going to write a statement substituting x is equal to 7 minus y in equation 2. Substituting x is equal to 7 minus y in equation 2. So 3 bracket, in the place of x I'm going to write 7 minus y minus 2y is equal to 11. 3 bracket 7 minus y minus 2y is equal to 11. Okay, so in the place of x in the second equation, I just wrote the value of x which I got from the first equation. So I used the method of substitution. Now what is elimination? I'm going to show you that. Actually, I eliminated x from the second equation. If you have realized, there is no x in the second equation now. Okay, so now it's easier to solve. So 3 sevens are 21 minus 3y minus 2y is equal to 11. So 21 minus 5y is equal to 11. So 21 minus 11 is equal to 5y, just like solving linear equation in one variable. 21 minus 11 is 10 divided by, 10 divided by 5 is equal to y. So y is equal to 2. Y is equal to 2. Okay, so if the value of y is 2, what should we do with the value of y? We have to substitute the value of y in equation 1. So again, substituting, we got the value of y already. Y is equal to 2 in equation 1. So what is the equation 1? X plus y is equal to 7. So x plus 2 is equal to 7. So x is equal to 7 minus 2. So x is equal to 5. So we got the value of x. We already got the value of y. Now we got the value of x. Now finally what you should do is you should write the final answer in a box. Okay, highlight that box properly so that teacher knows that this is the final solution. Okay, so in that box you should write x is equal to 5 and y is equal to 2. This is the solution of the given system of equations, and we have solved it using elimination by substitution method. So first we substituted the value of x in terms of y in the second equation, and from the second equation we eliminated x all throughout, and simply we got the value of y. We substituted the value of y in the in the first equation to find the value of x. That's how you do it. Is it simple? Do you think it's simple? Good, very nice. So we are ready to move to the second example. Now remember that these are all solved examples which are already there. See here, the answer is also given 5 and 2. Okay, so these are the solved examples which are already there in your textbook. Okay, you can see the method there also, but here what I'm doing is I'm giving you the steps, I'm explaining, and I'm also talking with it, showing you how it is done step by step so that your doubts are cleared. When you do the exercise, you have to apply the same method which I have done. I'm sure that you will have some doubts, but that will be taken care of. First you understand the method properly and try to apply, right? You will get the answer. Let's go towards the second question. Okay, let's do the second question. 2x plus 3y is equal to 7. Let me write it over here. Question number 2. 2x plus 3y is equal to 7, semicolon. That means the second equation. Always remember, you will have two equations in a question, pair of equations. If you want to find the value of x and y, you cannot do it with a single equation. So they will be giving you two equations. Okay, 2x plus 3y is equal to 7. 3x minus y is equal to 5. 3x minus y is equal to 5. So this is equation number 1. This is equation number 2, and you have to solve them. So again, let me ask you, which out of these two seems a simpler equation? To me, the simpler equation is equation number 2. So let's write equation number 2, that is 3x minus y is equal to 5, which can be written as 3x minus 5 is equal to y. So we got the value of y as 3x minus 5. Now what? Substituting y is equal to 3x minus 5 in equation 1. Substituting y is equal to 3x minus 5 in equation 1, what will we get? See, equation 1 is 2x plus 3y is equal to 7. Okay, so in the place of y, I'm going to write 3x minus 5 is equal to 7. So 2x plus, now I'll multiply 3 inside, so I'm getting 9x minus 15 is equal to 7. So 11x minus 15 is equal to 7. So 11x is equal to 7 plus 15. So 11x is equal to 22. X is equal to 22 by 11, and x is equal to 2. Okay, so we got the value of the value of x as 2. Now I'm going to put the value of x in one of the equations. Any one equation will do. But since I have used for substituting the value of y, I have used the first equation. Now remember one thing, I'm going to give you this very important suggestion. Please remember that. You chose the second equation for finding the value of y in terms of x over here. When you find the value of y from second equation, do not substitute back into the second equation. You will not get anything. Substitute the value of y which you got from the second equation into the first equation so that you get the value of x. Okay, now this value of x you substitute into the second equation, right? See, substituting x is equal to 2 in equation 2, what we will get? 3 multiplied by 2 minus y is equal to 5. 6 minus y is equal to 5. 6 minus 5 is equal to y. So y is equal to 1. Correct? So our solutions for the given equations are x is equal to 2, highlight, and y is equal to 1. x2, y1. I hope you understood the method of substitution. Okay, x2, y1, absolutely correct. Now we are ready to move ahead. Okay, one more question and we are going to make sure that this method is absolutely clear in your mind. Okay, this question is little complicated and it will be very helpful for you to understand how to solve these kind of complicated linear equations in two variable by using the method of elimination by substitution. So the equation is x plus 7 upon 5 minus 2x minus y upon 4 is equal to 3y minus 5. This is one equation. The second equation is, I'm just going to write it beneath this, there is not much space. 4x minus 3 by 6 plus 5y minus 7 by 2 is equal to 18 minus 5x. Now, if I ask you which of these two is the simpler equation, they both are equally complicated. And if you want to solve them by any method, first you need to simplify these two equations and bring them in their standard form. So what is the standard form of linear equations in two variable? It is ax plus by plus c is equal to 0. If you are able to bring any equation in its standard form, which I have written over here, then it would be easier to solve. Okay, otherwise it would be difficult. So let's bring them, try to bring them in the standard form. So here I'm going to take LCM of 5 and 4. See, here I'm going to write the denominator as 1 here as well, and I'm going to take LCM throughout. So when I take LCM, this becomes 5 4s are 20, 4 5s are 20, 21s are 20. Here 6 1s are 1, 2 3s are 6, and 1 6 are 6. Right? Take the LCM throughout, it will become 4 bracket x plus 7 minus 5 bracket 2x minus y is equal to 20 bracket 3y minus 5. Here also there will be 20 in the denominator. Here also there will be 20 in the denominator. Right? That's how you take LCM. Now you open the bracket, so it will become 4x plus 28 minus 10x plus 5y the whole upon 20 is equal to 60y minus 100 the whole upon 20. What did I do? I multiplied 4, open the bracket, I multiplied minus 5, open the bracket, this became minus 10x, and minus 5 into minus y is plus 5y, the whole upon 20. Here I multiplied 20 with both these terms. Now 20 will get cut from both the sides. So here I am going to get 4x minus 10x, that is minus 6x, plus 5y plus 28 minus 60y. This 60y will come this side, plus 100 is equal to 0. So this will become minus 6x plus 5y minus 60y is minus 55y plus 128 is equal to 0, which could be written in a much simpler way as 6x plus 55y. I'm changing all the signs. So negative signs become positive and positive sign becomes negative. Minus 128 is equal to 0. And this is your equation number. See, now I did not number the equations over here. I could, if I number them 1 and 2, then the simple version of equation number 1 would be called equation number 3, because number 2 is already given to this equation. So this equation gets number 3. So this is your simplified form of equation number 1, which is given the number 3. Okay, so now forget the original question. You have got simplified form of linear equation with you. Okay, in the same way you will simplify the second equation. Let's do that. So the second equation after taking LCM becomes 4x minus 3 plus 3 bracket 5y minus 7 is equal to 6 bracket 18 minus 5x. Here the whole upon 6, and here also the whole upon 6 will come. Okay, now you can cut this 6 from both the sides and simplify it further. So you get 4x minus 3 plus 15y minus 21 is equal to 18 6za. 18 6za. What is 18 6za? 18 6za is 128, right? 18 6za 108. I'm sorry, so I don't remember the tables, very bad. Yeah, 18 6za is 108 minus 6 5za 30x. Now what? 4x plus 15y minus 3 minus 21 will become minus 24 minus 108 plus 30x is equal to 0. So this will become 4x plus 30x 34x plus 15y minus 24 minus 108 will become minus 132. Okay, so here we get is equal to 0, and that is your simplified form of equation number 2. I'm going to call it equation number 4. So now we don't have to focus on equation number 1 and 2. We have to focus on equation number 3 and 4, because equation number 3 and equation number 4, they are the simplified versions of our original questions. They are the simplified versions of our original questions. Let me once check. 6x plus 55y minus 128 is equal to 0, and the second equation becomes 34x plus 15y minus 132 is equal to 0. Great. Now we have to use the method of elimination. So how to use the method of elimination? Select any one equation out of equation 3 and 4. Both are equally complicated. Okay, so just select one uh, term either containing x or y. So let's compare the terms containing x. The coefficient of x here is 34, the coefficient of x here is 6. Compare the term containing y, 55y and 15y. Now, the coefficient of x, which is 6, right? The coefficient of x, which is 6, is smaller. So it is easier to find the value of x in this term. Other two coefficients are all bigger. The least coefficient is 6, which is the coefficient of x in equation 3. So let's target that equation and simplify that. 6x plus 55y minus 128 is equal to 0, or I can write it as 6x is equal to 128 minus 55y, or x is equal to 128 minus 55y, the whole upon 6. The whole upon 6. So what is that? What is that? This is the value of x which we got from equation number 3. This value of x, I'm going to put in equation 3 again? No, I'm going to put it in equation number 4. I'm going to substitute this value of x in equation number 4. Let's do that. Okay, so substituting x is equal to 128 minus 55y upon 6 in equation 4. So 34 bracket, in the place of x I'm going to put 128 minus 55y, the whole upon 6, okay, plus 15y minus 132 is equal to 0. So that's the equation which I'm getting. Now what? Now I have to simplify this and find the value of y. How? 2 3s are 6, 2 17s are 34. Correct? Now I'm going to multiply 17 here in the numerator with both the terms. Okay, so 17 multiplied by 128. 17 multiplied by 128 is 2176 minus 17 multiplied by 55. 17 multiplied by 55 is 935 y. 17 multiplied by 128 is 2176. 17 multiplied by 55 is 935. The whole upon 3 plus 15y minus 132 is equal to 0. If you want, you can take 132 to the other side, so it is not involved in this LCM stuff. Okay, so 2176 minus 935 y, the whole upon 3 plus 15y upon 1 is equal to 132. 3 1s are, 1 3s are. Now what? 2176 minus 935y plus 3 gets multiplied with the 15 over here, 45y, the whole by 3 is equal to 132. Okay, so this will become 2176 minus 935y plus 45y. So basically I have to subtract 45 from 935 and it will give me, I think, 890. Yes, so minus 890y, correct, negative 890y is equal to 132 multiplied by 3. This 3 will get multiplied over here. So we get minus 890y is equal to, this will become 396 minus 2176. I know it is a big, huge calculation, but you can't help it. If you get a question like this is the way of doing it, okay? There are no shortcuts. So don't expect me to give you something really short. I'm taking my time and I'm explaining you, because if I go fast, I can go really fast without speaking and I can just show you the whole thing. I don't want to do that way. So I'm giving you this running commentary and doing it for you so that you understand how to do it. Okay, so here we have minus 890y is equal to minus 1780. Minus 890y is equal to minus 1780. Okay, so this gets cut right away and y is equal to 1780 divided by 890. Okay, 0 cuts. I think 89 twos is 178. Yes, 89 twos is 178. So this is going to get cut and you're going to get the value of y as 2. So this is one of the value which you got after so much of hard work. Value of y as 2. Now, this is not the end. You know that you have to find the value of x as well. So where will you substitute the value of x? In equation 3 or in equation 4? See, you can substitute the value of x anywhere, but we have got one simple format in which you can substitute the value of x, which is over here. Do you see that? This directly gives you the value of x and you can substitute it in this. It's not a problem, okay? Because this expression has been achieved from equation number 3 only. So okay, let's play safe and substitute the value of x in equation number 3. Substitute the value of y in equation number 3. I'm sorry. 6x plus 55y minus 128 is equal to 0. So I'm going to write substituting y is equal to 2 in equation 3. Substituting y is equal to 2 in equation 3. 6x plus 55y minus 128 is equal to 0, right? So here I'm going to get 6x plus 55 into 2 minus 128 is equal to 0. 6x plus 110 minus 128 is equal to 0. 6x minus 18 is equal to 0. 6x is equal to 18. X is equal to 18 by 6 and therefore x is equal to 3. X is equal to 3. So y is 2 and x is 3. Let's check. X is 3, y is 2. So yes, that's the answer, and this is the method. I hope you were with me while I was explaining everything, all the details. Uh, I explained the whole process of the method of elimination in detail, step by step, with 3 different examples. Okay, so this should be enough to understand what is the method of elimination by substitution. Now we are going to start with the next method, that is the method of elimination by equating coefficients. This is really interesting method, so please pay attention. Okay, elimination by equating coefficients. The first method was elimination by substituting. Substitution and elimination. What? Just a moment. Elimination by substitution. This is elimination by equating coefficients. Okay, let me talk about this method now. So we have 3x minus 4y is equal to 10, and we have 5x minus 3y is equal to 24. Now, how to solve these pair of linear equations in two variables by equating coefficients? So first of all, you should know that what are coefficients. See, the coefficients of x in both the equations are 3 and 5. So you can choose to equate the coefficient of either x or y, not both. You don't have to equate the coefficients of both x and y. No, you have to either equate the coefficient of x or equate the coefficient of y. So one important, you can say, hint I would like to give you. Choose the coefficients to be equated in such a way that they bear opposite sign. They bear opposite signs if possible. If possible, I'm going to write in bracket. Choose the coefficients to be equated in such a way that they bear opposite signs. Now, what are the coefficients of x in both the equation 3 and 5? What is the sign of 3? Plus. What is the sign of 5 ahead? Plus. Okay, forget about it. Let's talk about coefficient of y. What is the coefficient of y? Minus 4. What is the coefficient of y? Minus 3. They both have got minus signs. So here it does not matter which coefficient you will choose, because they both have got same signs, right? Generally we choose the coefficients to be equated in such a way that they bear opposite signs, but here they both the coefficient of x and y, they've got same sign, so it does not matter which coefficient you choose. One more thing, choose smaller coefficients so that you can equate them easily. Okay, whenever you choose coefficients of either x or y, choose smaller coefficients. So here 3 and 5, okay, they are fairly small. 4 and 3, they are also small. So here again in this question, it does not matter whether you choose coefficient x or y. Coefficients of x or y, it does not matter. Why it does not matter? Because both bear the same signs. There are no coefficients here which bear opposite signs. Okay, the coefficients of x and y both bear the same signs. Also, they both are fairly small. Okay, their value is not very large, so you can select any coefficient. So let me select the coefficient of x. Okay, so equating coefficients of x, equating coefficients of x by taking their LCM, equating coefficients of x by taking their LCM. So what is the LCM of 3 and 5? The LCM of 3 and 5 is equal to 15. The LCM of 3 and 5 is equal to 15. Okay, so how we will equate the coefficients now? For equating the coefficients, we took the LCM. We first chose the coefficient of x to be equated. Now we took the LCM of the coefficients, that is 3 and 5, which came out to be 15. Now I have to make this 3 into 15 and I have to make this 5 into 15. That's what the use of LCM was, right? I took LCM so that I can understand that what I have to convert into what. I have to convert 3 into 15 and 5 into 15. How do I convert 3 into 15? By multiplying it with 5. So if you multiply 3 with 5, that will not do. You have to multiply the whole equation, left side and right side, LHS and RHS, everything by 5. And here if you multiply, if you want to convert 5 into 15, you have to multiply it with 3. But you cannot just multiply 3 alone over here. You have to multiply the whole equation number 2 with 3. Okay, let's name the number the equation. That's a, I think, very important thing which we forgot. Right? So do you understand what we have to do? Multiplying, the next statement is multiplying equation 1 by 5 and equation 2 by 3. Multiplying equation 1 by 5 and equation 2 by 3. What do we get? Let's do it. 5 bracket 3x minus 4y is equal to 10, which is 15x minus 20y is equal to 10. So this is a entirely new equation. Hey, wait. I did not multiply 5 on the right hand side. So that's one mistake. Okay, don't do that. So 10 multiplied by 5 is 50. So this is an entirely new equation which has been formed by multiplying 5 with equation 1. Okay, so you have to write this statement and then multiply. Okay, so you get a new equation in place of equation 1. Name it equation number 3. Now multiply equation number 2 by 3. So 3 multiplied by 5x minus 3y is equal to 3 multiplied by 24. So what you get, 15x minus 9y is equal to 72. And this will be equation number 4. This is a new equation you got in place of your equation number 2. That is equation 4. Now, since you have got equation 3 and 4, and in both the equations, if you notice, the coefficients of x are what? They are the same. Okay. Now, after equating the coefficients comes the next part, that is elimination. Now you have to do the process of elimination. And how do you eliminate? Now, if you want to eliminate, how do you eliminate? So, for elimination, remember, I'm going to give you a hint over here. For elimination, check the signs. of equated coefficients. Check the signs of equated coefficient. Here it is plus, here also it is plus. If they have same signs, either plus or minus, if they have same signs, positive or negative, subtract both equations. Subtract both equations. If they have same signs, subtract both equations. Okay. If they have opposite signs, they means what? Who is they? They means the equated coefficients. If the equated coefficients have opposite signs, that is plus and minus or minus and plus, add both equations. Add both equations. So you understand? For elimination, we have to check the signs of equated coefficients. If they have same signs, you have to subtract both the equations. If they have opposite signs, you have to add both the equations. So now we know that these two terms, they both have got plus signs. So we have to subtract both the equations. So the next statement would be subtracting equations 3 and 4. See, please notice that I'm not writing subtracting equation 3 from 4 or 4 from 3. I'm just writing subtracting equation 3 from 3 and 4, because it does not matter which equation you subtract from which equation. You just have to subtract, and I'll show you how. See, for subtraction, you will first write equation number 3 or any of the equation, any of the one equation, the new equations, okay, in which the coefficients are equated. Don't write the original question. Is equal to 50. Then you will put a minus sign here, little far away, and write the second equation, that is equation number 4. 15x minus 9y is equal to 72. Then leave a gap of one line and then draw your line. Okay. Now, very important thing, you have done subtraction of algebraic expressions in class 8. You remember that chapter called Fundamental Concepts and Operations on Algebraic Expressions, right? If not, then I will teach you again. So when you subtract, remember, you need to change the sign of all the terms individually in the second line. So this 15x has got plus sign, it will become minus. This minus 9y will become plus 9y, and this 72 which has got plus sign, it will become minus 72. Now forget this sign which is there, forget their original signs. Now all you have to operate on these pair of linear equations is based on the basis of the signs which are written in the bracket over here. So 15x minus 15x becomes 0, minus 20y plus 9y, minus 20y plus 9y will become minus 11y. 50 minus 72 will become minus 22, right? So we have subtracted. Now we have got this thing, minus 11y is equal to 22, sorry, minus 22. Minus minus gets cut, so y is equal to 22 by 11, which is 2, right? So y is equal to 2. Okay, so since we have got the value of y is equal to 2, one of the variable we have found its value. Now you have to substitute this y in one of the equations. So you have got four options: equation 1 over here, equation 2 over here, or equation 3 or equation 4. So always remember, that you can substitute the value of y or x or any of the variable which you have got in equation 1 or 2 only, because they are the simplest equations. Or if you have got much more simpler equation, you have to choose that equation and substitute the value of x or y in that. So always choose a simpler equation for substituting the value of any one of the variable which you have got. Now according to me, the simplest equation is equation 1. 3x minus 4y is equal to 10. So I'll write substituting y is equal to 2 in equation 1. 3x minus 4y is equal to 10. Okay, so we have got 3x minus 4y is equal to 10. So 3x minus 4 bracket y, which is 2, is equal to 10. That is 3x minus 8 is equal to 10. So 3x is equal to 10 plus 8. So 3x is equal to 18 and x is equal to 18 by 3, which is 6. So x is equal to 6 is my solution for x. Highlight it. And the solution of y is equal to 2 over here. Correct. So y is equal to 2, x is equal to 6. X is equal to 6, y is equal to 2. These are our equations, the values of equations, solutions of the equations, yeah. And we have solved them, these equations, by using the method of equating coefficients. I hope the method is very clear to you. Equating coefficients. Okay. See, I'm solving the whole thing for you and showing you in detail. Okay. As we move ahead in the chapter, I'm going to teach you new concepts and new methods, but the solving part will be left to you when we move ahead in the chapter, because by then you should have that grip on the topic, on the concept, that you should be able to solve it on your own. Okay, again we have one more question. I think we have few more questions we can solve. But this one, which I have in front of me, is by using the method of elimination by equating coefficients, which we just did. Okay, let's try. Okay, so the first equation is x plus y is equal to 3.3 and 0.6 divided by 3x minus 2y is equal to minus 1. Equation number 2. Okay, so we have got these two pairs of linear equations. We have to solve them by using the method of elimination by equating coefficients. Before we go and solve them, I would like to bring equation number 2 in much more simpler form. Okay, so I'll do one thing. I'll shift the denominator to the other side. It will become minus 1 multiplied by 3x minus 2y. So 0.6 is equal to minus 3x plus 2y, or you can say 3x minus 2y is equal to minus 0.6. Okay, so let me I could give this equation number 3, but I don't want to. So I'm going to give this one equation number 2. This one number 2. Okay. So I've got x plus y is equal to 3.3 and 3x minus 2y is equal to minus 0.6, and I have to solve this by using the method of elimination by equating coefficients. Okay. So now, as I told you in the previous question, what should be the criteria for choosing coefficients? So I have written over here, choose the coefficients to be equated in such a way that they both bear opposite signs to each other. Now the coefficient of x over here is 1 and the coefficient of x over here is 3. Both bear positive signs, plus signs. Here the coefficient of y is plus 1. There is no number, that means there is 1. Okay. Here the coefficient of y is minus 2. Okay, so plus 1 and minus 2. I'm going to select y as variable whose coefficients I'm going to equate. Why? Because the signs in front of y, that is positive and negative signs, which can easily be, you can say, uh, eliminated because they've got opposite signs. Okay, so you will know that why I'm selecting y. Okay, why I'm selecting y. Okay, now what? See, here the coefficient of y is 2 or minus 2. Here the coefficient of y is 1 plus 1. Okay, so I have to make this coefficient over here in equation 1 as 2. So multiplying equation 1 by 2, what will I get? 2 bracket x plus y is equal to 2 multiplied by 3.3, that is 2x plus 2y is equal to 6.6. 2x plus 2y is equal to 6.6. Now this is equation number 3. This is your equation number 3. You have transformed the first equation into a new equation by multiplying the whole equation by 2. But what did you achieve? You will see over here. What is the coefficient of y? 2. What is the coefficient of y here? Originally 2, but they both bear opposite signs. Now what? I gave you one more idea here. For elimination, for moving to the next step, that is elimination, first step is equating coefficients. That is done. Now for elimination, check the signs of equated coefficients. If they have the same sign, subtract both the equation, and if they have opposite signs, add both the equations. So in our case, in both the equations, we have got which signs? We have got opposite signs because here 2y has got minus sign in front of it, here 2y has got plus sign in front of it. So what we are going to do? We are going to add both the equations. So adding equation 3 and 2, what do we get? 2x plus 2y is equal to 6.6 plus 3x minus 2y is equal to minus 0.6. No need of leaving a gap or anything because there is a plus sign. We are not going to change any signs over here. So simply adding 2x plus 3x is 5x, 2y minus 2y gets cut, plus 2y minus 2y, and 6.6 minus 0.6 is nothing but 6. So therefore x is equal to 6 by 5, which is 1.2. Here you go, you get the value of x, right? So the techniques which I'm showing you, that is how to choose the coefficient, and then if the coefficients have got opposite signs or same signs, what to do with them, how to eliminate, these things will make your process easier. Now what is left? We just have to substitute the value of x in one of the equations, correct? So substituting x is equal to 1.2 in equation 1. So we are going to write 1.2 plus y is equal to 3.3, right? We are just going to replace x by 1.2 in equation 1. So y becomes 3.3 minus 1.2. So again, let me remind you what I told you about substitution. When you get one of the values of the variables, either x or y, choose that equation for substitution, which is the most simplest out of all the equations. So I've got equation 1, 2, 3 over here. Equation 1, equation 2, equation 3. Out of all these equations, equation 1 is the most simplest. That's why I selected that. So y is equal to 2.1. Y is equal to 2.1. Right? So this is the value of y. This is the value of x. 1.2 and 2.1. Easy. Very easily we got the answer. Let's go ahead. Now this is a very interesting kind of equation which we have got over here, and I want you to understand the method which I'm going to use for solving this type of equation, and what is the pattern which we are seeing in this type of equation. That is also very interesting to note. Let's check. So this is the last question for this video, because after this we will be going to the method of cross multiplication. That's our next method, right? So please pay attention on this particular question. 65x minus 33y is equal to 97, and 33x minus 65y is equal to 1. Correct? Okay. Now what? See. Here, see the pattern. What is the coefficient of x? 65. In first equation, the coefficient of x is 65. What is the coefficient of x in the second equation? 33. Okay, no big deal. What is the coefficient of y in the first equation? 33. What is the coefficient of y in the second equation? 65. Do you see the pattern? The coefficients of x and y are interchanged. Are interchanged. So x had the coefficient 65 here, which became the coefficient of y in the second equation, and y had the coefficient of 33 in the first equation, which became the coefficient of x in the second equation. So coefficient of x and y are interchanged, and whenever coefficient of x and y are interchanged, you will use a separate different technique which I'm just going to show you. You will not do it with our normal technique of, you can say, um, elimination by substitution or elimination by equating coefficients. You will not do that, because those techniques will become very lengthy and long. You will apply eventually one of those techniques, but before applying elimination by substitution or elimination by equating coefficients, you should be simplifying these pair of linear equations which have got fairly large coefficients. 65 and 33 are huge coefficients. If you want to equate a coefficient, you have to take LCM of 65 and 33, and you don't want to do so much of calculation, right? So there must be another way out. And what is that? See, I'll tell you. The first step which you are going to do is, whenever you get this kind of case, okay, whenever the coefficients are interchanged in both the equations, big numbers and interchanged, you can do this: adding equation 1 and 2 directly. Okay, adding equation 1 and 2. Let's see what we get. 65x minus 33y is equal to 97 plus 33x minus 65y is equal to 1. When you add them, you get 98x minus 98y is equal to 98. Take 98 common. X minus y is equal to 98. Cut 98 from both the sides. X minus y is equal to 1. And this is equation number 3. Did you see that what happened? The equation got simplified to another level. So you can solve this equation now which you have got very easily. Okay, but single equation cannot be solved, right? So you will do one more thing. Subtracting equation 1 and 2. Subtracting equation 1 and 2. 65x minus 33y is equal to 97 minus 33x minus 65y is equal to 1. Draw a line, leave a space and draw a line. Change the signs. Minus will become plus, plus will become minus. 65 minus 33. Okay, so this will become 32x 33 minus 33 plus 65y plus 32y is equal to 96. 32 comes out common. X plus y is equal to 96. X plus y is equal to 96 divided by 32. X plus y is equal to 3. And this is equation number 4. This is equation number 4. X plus y is equal to 3. Correct? Right. So what lesson you have learned from this? The lesson which you have learned over here is that whenever you have got some complicated equation, try to simplify it. That's number one. How to do that? Try to understand the pattern. Initially, when we started solving some questions, I think by far this was the most you can say complicated question we had got, and we simplified it and further reduced it and found the values of x and y, right? Over here the pattern was visible that the coefficients of x and y were interchanged, so we first added both the equations and then we subtracted both the equations and we got two new equations. We did not get values of x and y, but we got two new equations from which we can find the values of x and y easily. So let's first write these new equations. So equation 3 is x minus y is equal to 1, and equation 4 is x plus y is equal to 3. Now what? Now you are going to add equation number 3 and 4. Why? We are going to use the method of elimination by equating coefficients. I want to ask you, what is the coefficient of x here? Plus 1 plus 1. What is the coefficient of y? Minus 1 plus 1. So we are going to select the coefficient of y for equating, but they are already equal. So we don't have to use equating coefficients. So what we will do? We will directly go to the step of elimination. So how to eliminate the coefficients which are already equal but having opposite signs? If the coefficients which are already equal are having opposite signs, what we do with them? We just add them. We just add them. Okay, so we add both the equations. Adding equation 3 and 4, what do we get? X minus y is equal to 1 plus x plus y is equal to 3 Okay, so here we get 2x minus y plus y gets cut is equal to 4. X is equal to 4 by 2. X is equal to 2. This is equation number, sorry, this is the solution of x. Now you have to use substitution. So substituting in any of the equation you can substitute. Substituting x is equal to 2 in equation, let's say 4, no problem. So x plus y is equal to 3, 2 plus y is equal to 3, so y is equal to 3 minus 2, so y is equal to 1. So we have got the value of x as 2 and the value of y as 1. x2, y1. Did you understand the pattern? Correct? x2, y1. Perfect. Now see, we have completed first two parts of the chapter, right? Exercise 6a and 6b as per your textbook is done. We are going to start with method of cross multiplication in the next part, and then equations reducible to linear equations, and then the word problems. That is basically three parts of the chapter are remaining. We will cover them. I want you to finish the first two exercises and make sure that you can solve these equations. You can practice well and solve these equations with the methods which I have taught you without any problem. Only then you will be allowed to go ahead and solve the next parts. Okay, so please begin and start solving exercise 6a and 6b. See you in the next class. Bye bye.